Okay, next let's talk about the wage elasticity of labor supply. Elasticity is the responsiveness of labor supply to changes in the wage rate. It's, more broadly speaking, a measurement of price sensitivity. And you may have heard of elasticity in other contexts. For example, we can measure the price elasticity of demand of a particular good and look at how the quantity demanded for that good changes in response to price changes. Here, we're really doing the same thing, but we're looking at how responsiveness, the quantity of labor supply is to changes in the price of labor, which is the wage rate. The formula we use is illustrated here. The elasticity of labor supply is equal to the percentage change in quantity of labor supplied divided by the percentage change in the wage rate. Now, if you happen to have the percentages, you can just plug them into the numerator and denominator and calculate accordingly. For example, if I know that the percentage change in the quantity of labor supply is 50%, and I know that the percentage change in the wage rate is 25%, then I would take 50% divided by 25%, and the elasticity of supply would be 2. However, we often don't have the actual percentages available. We need to calculate them. So that brings up the question of how are we going to calculate the percentages? And there's two methods. We're going to focus on what's known as the midpoint method. The midpoint method calculates the percentage changes in the numerator with this calculation here, and calculates the percentage change in the denominator with this calculation here. Let's run through an example to illustrate this process. It says, suppose a worker decreases his labor supply from 35 to 25 hours per week when the wage rises from $8 to $12 an hour. What is the wage elasticity of supply? To do this, let's shift over to a paper so we can do our computations. Now, here we've got the same PowerPoint, but we're going to plug in some numbers. Again, we're going from $8 to $12 per hour. So to calculate the percentage change in the wage rate, we're going to use this midpoint method. And so I'm going to go ahead and write over here, just kind of duplicate the numerator and the denominator. I'm going to write the change in the wage rate is $4, and we're going to divide that by the sum of the wages divided by 2, which is just the average. So if we go from 8 to 12, then 8 plus 12 is 20 divided by 2, which is 10. Okay, so we can put 10 is the average, also known as the midpoint. So that's why we call this the midpoint method, because in calculating our percentages, we're using that midpoint as our point of reference for the percentage change here in wages. Okay. And then for the numerator, we have the change in quantity over the midpoint of the quantities. Well, the quantities went from 35 to 25. And so we have a change of negative 10. So we're going to put negative 10 as the change in quantity, and then we're going to divide that by the midpoint. Well, 35 plus 25 is 60, divided by 2, which is 30. So now we have our percentage fraction in the numerator and our percentage fraction in the denominator. The next thing we need to do is actually calculate. Now I'm going to jump down here and calculate these percentages. Well, negative 10 over 30 is negative 0.33. And then positive 4 over 10 is 0.40. Then we can take negative 0.33 and we can divide that by 0.4 and we get 0.825. So this is our elasticity of labor supply. Now let's go back to the PowerPoint and work through some important aspects of the wage elasticity of labor supply. Keep in mind as we go through this what our actual elasticity was. Again, it was negative 0.825. Signage matters. If you get a positive coefficient, then that means that the numerator and the denominator move in the same direction. Either you have a positive value here and a positive value here, or you have a negative value here and a negative value here. If wages go up, labor supply goes up. If wages go down, labor supply goes down. In that case, the substitution effect dominates because recall that the substitution effect said higher wages would cause higher labor supply. If you get a negative coefficient, the income effect dominates. To get a negative coefficient, you must have opposite signage in the numerator and denominator. If you have a positive increase in labor supply, then it must be that wages went down. Or if you have a negative change in labor supply, it went down, that comes from a positive change in wages. So this inverse relationship would mean that the income effect dominates. As wages go up, people would be working less. Sensitivity matters. We can think of elasticity coefficients in 5 ways. An inelastic coefficient has an absolute value of less than 1. To get the absolute value, you just calculate your elasticity of supply and then get rid of the negative. So it'll always be a positive value. If you have an elastic sensitivity, that comes from an absolute value greater than 1. Unit elastic means an absolute value equal to 1. Then you have these extremes. Perfectly inelastic would be an absolute value of 0, and perfectly elastic would be an absolute value of infinity. Most of what we find in our analysis in labor markets is going to be either inelastic or elastic, because these are a very broad range, either greater than 1 or less than 1. If you were to get a perfectly inelastic labor supply relationship, then that would imply that if wages went up or down, there would be no changes in the labor supply. And while that might be realistic over some ranges, if the wage goes from, say, $8 to $12 an hour, it is possible there's no change in labor supply. But if the wage range were to go all the way down to 0 or all the way up to, 1,000, you would definitely start to see changes. So a perfectly inelastic labor supply relationship to wages is not really very likely. And then perfectly elastic would be a case where if the wage were to go down by even a penny, labor supply would drop to 0. And again, that's not likely either. So these may be theoretically plausible, but not something we see that often in the real world. And then this is just one point, so that might occur in transition between inelastic and elastic. But let's go ahead and revisit our elasticity of supply coefficient, which was negative 0.825. Well, that means that we have an income effect that dominates, which makes sense because wages went up and you had a decrease in labor supply. So this person is responding to the higher wages by working less. Sensitivity for us, we have negative 0.825, convert that to an absolute value by getting rid of the negative, and you have 0.825. Well, 0.825 is less than 1. As a result, this is an inelastic response. You might be thinking, well, that seems odd because, yes, wages went from 8 to 12, but this person cut their work week from 35 to 25 hours. It seems like that's pretty responsive, but remember, it's all about percentages. So what happened here is that the percentage change in quantity of labor supply, that went down by 33%. But the percentage change in wage rate went up by 40%. So you can see why this would be inelastic, because the change in quantity was less in percentage terms than the change in the wage rate. Again, let me just pull this over here real quick so you can see the numbers. The wage rate goes up by 40% and the quantity supply goes down by 33%. So it's considered unresponsive. It's considered inelastic simply because the change in quantity supplied in percentage terms was less than the percentage change in wage rates. Now let's move on to another topic related to labor supply, and that is the idea of non-participants and what we call corner solutions in our model. A non-participant is somebody that has chosen 24 hours of leisure, has chosen not to work at all. Non-participants are corner solutions because in our model, notice over here in the corner, you have 24 hours of leisure. So they're choosing a point that is in the far right lower corner of our illustration. Let's look at one example of what might cause a corner solution and non-participation. Imagine we have an individual that initially is working and they have wage represented by W up here. That also represents their income per day based on the wage. This is their budget constraint, and for them, they choose the optimizing outcome where the highest indifference curve is tangent to the budget constraint. That corresponds to 16 hours of leisure and therefore 8 hours of work. Imagine that this person, for one reason or another, experiences a decrease in wages. So instead of W being their market value, it's now W prime. That rotates our budget constraint down and creates this new constraint and a new optimal outcome. Note that the highest indifference curve this person can get to now is I2. This indifference curve is tangent at 24 hours of leisure. So they're still using the same optimizing process. When the wage was high, they optimized at the tangency of the highest indifference curve. Now the wage is low, and they're optimizing at the tangency of the highest indifference curve. But this tangency happens to correspond to 24 hours of leisure. This tangency corresponds to 0 hours of work. Therefore, because of the wage decrease, they have went from being a participant to a non-participant. Everyone has a wage below which they would choose to not participate. They would choose not to work. It will vary by individual. Perhaps some of you, if the wage goes below $20 an hour, you won't work. For others, maybe the wage would have to go below $5 for you not to work. Regardless, there is some wage that is necessary to induce work, and that's the reservation wage. So who are these non-participants? Some groups come to mind. One is young people. Young people have a low wage, teenagers generally speaking, and as a result, labor force participation among teenagers is lower than other age groups. So for teenagers, we are more likely to see this corner solution emerge. Another group is elderly people. People who at one time may have commanded a high wage in the marketplace, but because of their age and condition, they now would command a lower wage. For these older people, they're more likely to not participate, and we often call that retirement. Well, retirement is just another way of saying we have 24 hours of leisure, a corner solution, a non-participant. There are other possibilities, but in each case, there is a low wage that is inducing someone to not participate.